Okay, find the equivalent capacitance of the arrangement of capacitors shown in the figure on the left. Okay, find the charge on the 4 microfarad capacitor. Okay, 4 microfarad capacitor. Alright, so these questions want us to find the equivalent capacitance first. That means the total capacitance. Okay, equivalent capacitance, and then finally we need to find the charge on the 4 microfarad 4 microfarad capacitor. So I need to label first. This one you can put as C4, this one as C1, according to the capacitance value. C5, this one is C3. Just put like that, yeah. So this charge on 4 microfarad capacitor I can put as Q4, right? Q4. Okay, here we have 10 volt. 10 volt actually is the total voltage. Okay, and this is the total voltage. Yeah, total voltage is 10 volt. All right. Okay, this circuit can be redrawn into this form. Yeah, if I want to redraw, okay, I can redraw this circuit into this circuit I can redraw into this form. Yep, this way, yeah. So this is C1, C5 over here. Here we have a C1, C5, C4, here C3, and here we have the total voltage, yeah, total voltage. Okay, all right. So now we can find our total capacitance. All right, can find our total capacitance. Always work from, remember, always work from branch, and we go to our main circuit. So this is our branch, C1 and C5 is our branch. Okay, work from here. So we combine this, and we will get. Okay, let me redraw it. Yeah. Okay, I've redrawn already. Okay, this C1 and C5 is in parallel. Okay, can combine this. All right, let me draw. This one can be combined. This is a parallel. Okay, it's parallel because the connected two legs. Okay, and this one become C1 5. Okay, C1 5, and then this one is C4. This one is C3. Okay, okay, hold on a second. Okay, so let us do this part first. Okay, how to combine this parallel. Okay, let us do some calculation for parallel. Okay, parallel, this one is parallel. Parallel capacitor becomes stronger. Yeah, they plus together, right? Parallel capacitor, they plus, right? So we can put as parallel. Okay, so C1 5 is equal to C1 plus C5. Okay, what is C1? C1 is 1 microfarad. Yeah, maybe I should write it again, more clearer. This is 1, this is 4, this is 5, 3, this is a microfarad. Yeah, everything is microfarad, and this is 10 volt. Okay, now it's clearer, right? 1 microfarad, 4 microfarad, 5 microfarad, 3 microfarad, 10 volt. Okay, so we are C1 and C5 is 1 microfarad and 5 microfarad. 1 micro plus 5 micro, so you have 6 microfarad. Okay, that's for C15. Okay, 6 microfarad. Maybe I should never mind. Okay, never mind. Okay, now I got ready. So now this one can be combined also. Yeah, now we can combine this. These two are series. Okay, work from here. Series. Okay, because they connect. Just now this one is parallel because they connect. They have two legs connected. This one is series because they have only one leg connected. All right, series. All right, and then after they combine, they form C415, and then this is C3. Yeah, so series connection. Okay, so series connection. Okay, if capacitor in series capacitor connected in series, the capacitor becomes smaller, so it's 1 over C. Yeah, it's 1 over C. See, 1 over C. So 1 over C415 equal to 1 over C4 plus 1 over C15. All right. So C4, what is C4? Let's find out what is C4. C4 is 4 microfarad. 4 microfarad. And C15 just now is 6 microfarad. Yeah, 6 microfarad. Okay. Okay, let's add up. Yeah, let's total up. 1 over 4 micro plus 1 over 6. Okay, I got 5 over 12. 5 over 12 microfarad. Is this correct? Is this the answer? No, yeah, this is not the answer yet. Because this is still 1 over C, so you have to invert. You have to invert the whole thing. Okay, you have to invert this thing, and then only you can get the answer. Yeah, so 1 divided by the answer, and I got is 2.4 microfarad. Okay, that is C415. All right, so I got already C415. Now this, you can combine this, and these two are parallel because they connected both legs. You see that? They connected both leg connected, so these are parallel. After they connect, they form the C equivalent, or we can say this is a C. You can say 3415 also can. Yeah, or you want to say as a C total also can. Yeah, or sometimes you put as C effective also can. Yeah, and this is the V total. Yeah, V total. Okay, so now I want to get it. So this is a parallel combination. Parallel combinations, yeah, parallel combination, capacitor becomes stronger, so they plus together. So I got the C total already. Yeah, C equivalent. C total, which is C total. Yeah, so it is C415 plus with C3. As I told you, parallel, they plus together. Yeah, so C415 just now got me 2.4 microfarad. 2.4 microfarad plus the C3. C3 is 3 microfarad. 3 microfarad. Okay, 3 microfarad, and finally I get 5.4 microfarad. Okay, so that's the answer. 5.4 microfarad, C equivalent. Is it correct? Yes, that's correct. 5.4 microfarad. That's correct. Okay, that's correct. So now I think the problem starts here. how to find the charge. How to find the charge on only 4 microfarad. How to find the charge on only 4 microfarad. Only this one. How to find the charge on here. Okay. How to find the charge on here, on the 4 microfarad. How? So that one you need the relationship for the charge, voltage, for series and parallel. You must know this lah. Must know this. Okay. Must know the charge and voltage for series and parallel. Okay. Let us do it one by one. Okay, first thing we must know about the C equivalent, the C total. Okay, as I told you before, the flow is this one. Yeah, the flow is always you find the C total, then once you got the C total, we can find the V total, find the Q total, and from there we can find the individual charge or voltage. Okay, that's the flow. So right now we already got our C total. And we also have our V total. Let's write down our V total here. Our V total is 10 volt. Our V total is 10 volt. Yeah, 10 volt. We also got our C total. Okay, so the flow is always this way lah. Yeah, the flow is always get the C total first, then you can get the charge total or voltage total. Then you can get the individual voltage or individual charge, yeah, for each capacitor. All right, let's move on. We got our C total, V total. Now we want to find the charge total. We want to find the charge total. Yeah. Okay, let's do it. So charge total. So maybe you can do it over here. Okay. So we can do it over here. Our Q equal to CV. Yeah. Q equal to CV according to our notes. Q equal to CV. Just use this one. Q equal to CV. Yeah. So since all these are total, Q total, C total, V total, we already have our C total, V total. We can find our Q total. Okay. So C total is 5.4 microfarad, and our V total is 10 volt. So times 10, so this is 54. Is it coulomb or microcoulomb? Which one? Of course, microcoulomb, because this one is microfarad. Because this one is microfarad, so you must have microcoulomb. Don't forget the micro. Don't miss out the micro. Micro itself is exponent -6. Okay. Okay, I got the Q total already. I can also write it as over here. I can write it over here. My Q total I got is 54 microcoulomb. Okay, how will this help me? The Q total, how will it help me? Okay, let's find out. Yeah, let's find out. Okay, let's put it over here first. Okay, now build some relationship. Okay. Let's look one by one. Let's look one by one. Okay. Okay. I think Q total, this one we leave it first. Maybe later we will use it. Yeah. Maybe later we will use it. Maybe we just use the V total. Yeah, V total, because this one also can help us to find other information. Yeah, look at here. I just want to put it over here. V total is 10 volt here. V total 10 volt. 10 volt. Yeah. Okay. I want to rub this off. Okay. Make things less messier. All right. Okay. Like this is better. Okay. So we know that this is V total, right? V total. So the voltage across like this one, you see this parallel circuit, this V total. So V total is 10 volt. So we can say that this part also this V3 is also 10 volt. Okay, this V415, okay, V415 is also 10 volt, because we know that okay, see that, because we know that about this, we know the parallel circuit, right? Parallel circuit, this parallel circuit, the voltage is the same. The V total is equal to V1 equal to V2 equal to V3, because all of them connected across the battery. They have the same, same voltage. All of them have the same voltage. V total equal to V1 equal to V2 equal to V3. So what I can say is, this parallel circuit, for this parallel circuit, the V total is equal to V3 equal to V3 equal to V415, which is 10 volt. Okay, this might help us. Yeah, this will help us. So I change a little bit the color, make it, whatever, blue. Yeah. Okay. Okay, so we got because we want to find Q4, right? We want to find charge on C4, so we need to work step by step. Okay, going to this branch, C415, because the C4 is inside C415, right? C415. So you work backwards. From here, just now we go from left to right. Now we go from right to left. That's why it's good if you draw all the picture. You draw all the picture, then you use the picture to get the information. The picture will help you in the return. Understand? Okay, so you see, because the V total is equal to V3 equal to V415. Okay, all of them has 10 volt, 10 volt, 10 volt, 10 volt. So we can say V415 is also 10 volt. Okay, that's very important. Okay, maybe you write it over here first, because parallel circuit. Okay, now I want to do just now this is part A. Okay, now this is part B already. Yeah, this one is part A for the first questions, and then this part B for the second questions. Parallel. Okay, parallel. So parallel circuit, so the V total is actually equal to V3 equal to V415. Just look at here, V total equal to V3 equal to V415, which is 10 volt. Okay, because of parallel circuit. And then from here, and then later we go from here. Yeah, this 10 volt, yeah, we go to here. Look at here, this part, this 10 volt, V415 is 10 volt. Over here is also 10 volt, over here is also 10 volt, right? This is also V total. This V415 is actually over here is V4, and over here is V. I just want to, this thing is okay. This is series already, right? Series, yeah, between C4 and C15 is series. So this one is V15. So between V15 and V4, they are in series. Okay, they are in series. So I can say, what I can say is, right, I can write over here, series. Okay, so I can say the V415, okay, V415 just now is equal, series. If series is, the voltage is plus. See that? If series, the voltage is V1 plus V2 plus V3, yeah, plus together, yeah, plus together all the voltage. So V415 is V4 plus V15. V4 plus V15. Okay, which is also 10 volt. Okay, it's 10 volt. Now how to do, how to continue, how to continue. I don't think I can continue from here, but what is important is okay, I cannot continue from here. You see that I just know the relationship, but I want to find the Q4, but I cannot know the V4 from here, so I'm stuck. I'm stuck. So if I cannot do from V voltage, I do from charge. Understand? I do from charge. So for how to do from charge, we go back one step, go to the parallel. We know that this V415 is 10 volt. Maybe I can find the charge for this capacitor Q415. You see that? So from here, I jump it. Okay, I want to find Q. Q equal to CV. Q equal to CV. So since I know V415, I also know C415 because I already have the C415, right? Isn't it? I already have the C415, 2.4 microfarad, right? Yeah, 2.4 microfarad. I also have the V415, 10 volt. I can find the Q415. 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 Okay, so just now is C415 is 2.4 microfarad. Okay, 2.4 microfarad. So 2.4 microfarad multiplied by V415. V415 is 10 volt. Okay, 10 volt. Okay, so I get 24 microcoulomb. All right, I got 24 microcoulomb. So I already got the charge 415. Okay, this might be helpful. Why? Because later I can use this charge in the series. Can use the charge in the series. So in series, I better not use the voltage. I use the charge. Now I can use the charge. Yeah, for this part. I move from here. Okay, I find use the series. You know, about the series, talking about the series, the charge is the same. You see that? Q total equal to the Q total equal to Q1 equal to Q2 equal to Q3. So what I can say is this Q415, this Q415 here. Okay, maybe I can write something here. Here I already have Q415. Q415 is also equal to Q4 equal to Q15. Understand? Because it's series. Understand? Q415 is equal to Q4 equal to Q15 because they are series. They are series, so the charge is equal. The charge is the same. So I can put it this way. So so Q415 because series, yeah, because they are series, you know. Never mind. Series, so Q is equal to Q415 is equal to Q4 equal to Q15. Understand? Q415 equal to Q4 equal to Q15. So okay. Oh, I got the Q4 already. So Q4 is also equal to 24 microcoulomb. So that's my answer for Q4. See that? See that? So I got my answer already. Yeah? Unexpectedly, yeah? So I got my Q4 easily. So that's my Q4. Yeah, Q4 is actually Q415. Yeah, equal to Q415, which is 24 microcoulomb. Is the answer correct? 24 microcoulomb? That's correct. 24 microcoulomb. That's correct. Okay. So if you see Q4 and Q15 is 24 microcoulomb. So I want to verify this. Just now I got the Q total. And never mind, I just forget about it. Okay, just this one. So Q4 is 24 microcoulomb. That's it. Yeah, that's it. So that's how we solve the questions. You must know this relationship very well. If series, the charge is the same for all capacitor, but the voltage is added up, V1 plus V2 plus V3. But parallel, the voltage is the same, V1 equal to V2 equal to V3 equal to V total, but the charge is added up, Q total equal to Q1 plus Q2 plus Q3. This thing you must know. Alright, if you know this very well, then this one you can work around. Surely finally you can get the answer. Alright, do it step by step. Okay, I hope you understand the whole thing, and see you in the next video. Bye.